So hopefully you get a sense of why I include Chapter 9 with Chapter 1 and 2. As we look at correlation and regression, I only focus on very, very basics of linear correlation and linear regression because it's another way to really summarize variable. We're not going to make statistical inference with linear correlation in this course. So try to keep it very simple and basic. Correlation just means that two variables are related to each other. It does not mean that one variable causes a response in the other variable. In order to have something like that, we need to design an experiment. It'll be a lot more specific. But it is helpful sometimes if we have an independent or an explanatory variable. Usually that's our x variable that lives along the horizontal axis. We look to see, does that variable explain the other variable? So for example, height versus weight. Generally, as somebody gets taller, they also are going to be heavier. So height in general would be the explanatory variable and weight would be the response. If we had something like SAT math score and SAT verbal score, neither one of those two variables really explains the other one in context, but they would definitely be correlated or related to each other, but either one could be the x or the y variable. Okay, so when we look at this, we want to look at a specific type of graph or plot, and that would be our scatter plot. So in the previous chapter we saw histograms, we saw the box plot. All of those are graphs for just one variable at a time, but when we have two, we wanted to look at a scatter plot and see if there's an association. So in this first graph to the top left, I can see there's a very strong negative correlation. As the x variable gets larger, the y variable is getting smaller in general. And here we have a strong positive correlation. As x gets larger, y gets larger. Down here, just random scatter would suggest there's really no correlation. And then if I notice a really bending, curving pattern in the data, it's not a linear correlation. Still certainly a correlation, but not linear. So what I'd like to do with this first example is jump to the calculator, okay, and show you how we would construct this scatter plot on our calculator. So the first thing I'm going to do is, and same as we've done before, that's why I wanted to cover this chapter on the first test, we go to Stat and we go to Edit. Big difference now though is that we have two lists we have to enter. So I'm going to go up to L1, I'm going to press clear, and here we are in our edit mode, and I'm going to take these two lists. GDP is going to be the x variable, that'll go in L1, and CO2 in L2. So let me enter those in the calculator. So once I have my two lists entered in the calculator here, similarly to when I wanted to make my box plot in the last chapter, we hit second y equals for the stat plot. So I hit second y equals. I want to press enter. All the other plots are off. Plot 1 is on. But I want to arrow down now. Instead of using the box plot, I want to select that scatter plot icon. So I want to make sure that this is highlighted. I press enter. Everything is good here. We want L1 and we want L2. And again, remember the shortcut to getting our scatter plot is to press the zoom key and the number 9. So we can see our scatter plot here. Let's take a look at the lecture slides and see what the scatter plot looks in. So we see the same features here that we saw on our calculator. We can toggle back and forth to the calculator screen. We see what we can see here is we have a strong positive linear correlation between those two variables. Okay, and we could do the same thing here. Hours of exercise, GPA, construct that scatter plot. It's the same steps. Okay, and this is walking you through what I just showed you. Okay, the correlation coefficient. Let me show you how we go about calculating that. But this is just one number, and it tells us two things. It tells us how strong the relationship is. Is it weak? Is it moderate? Is it really strong? And it also tells us the direction of the association. Is it positive or is it negative? Okay, so it's going to have a sign and it's going to have a value. The closer this value gets to an absolute value of 1, the stronger the relationship. If the value of r is close to -1, it's a strong negative relationship. If it's close to +1, it's a strong positive relationship. So we have perfect positive correlation here, perfect negative correlation here, and then probably a correlation pretty close to 0 here. And you can see everything in between. This would be a correlation of a +1, -1. Every point lies right on a line, on the same line. Every point on the same line, but it's negative. Here we have a pretty strong correlation with an R value, and it's positive of 0.81. Strong negative would be an R value around -0.9. Okay, no correlation in these two cases. Kind of random scatter in the scatter plot. Okay, so we're not going to need to do any heavy lifting with these calculations, I have these same numbers that are still in my calculator. I want to show you how we would go about calculating the correlation coefficient R and let the calculator do that for us. So remember, we still have this data in the calculator. So there's an extra step that I'm going to need you to follow here if you want to write these steps down. But once you execute this once, you shouldn't need to do it again. I'm going to hit the second key and the 0 button. So I'm going to hit second, 0 for my catalog. Now you can press the X inverse button to quickly get down to the D's. I need to get into the D area here, so you can just arrow down to it. I think I can quickly move there with that X inverse key. But what I'm looking for is I arrow down. I don't want to go too fast. I want to find the diagnostic on command. It's right down here. So make sure my arrow is next to that. I'm going to press enter. And now the calculator is waiting for me to execute. It doesn't look like anything great has happened, but now when I do my linear regression calculation, it will find R and R squared for me, which is going to be really helpful. So just like we have in the chapter 2, we're going to lean on this stat key. So I'm going to press stat. And now, remember, I already edited. I put my 2 lists in there. I'm going to go over to calculate, and I want to pick number 4 this time. This is our linear regression. This is more the topic of the second section in chapter 9. But we can jump to it now because it's going to be helpful here. If I want to graph my regression equation, okay, and I'll go through these steps. You can rewind and watch them. I want to tell the calculator to write the equation of the regression line and scatter plot it in the scatter plot that we just put that we just graphed. I want to graph it with the scatter plot. So if you don't have a prompt that looks like this, don't worry. I'll show you what your screen ought to look like. But the next couple keystrokes are going to be the same no matter what. I want to tell the calculator to graph this as an equation of y. So I need to come over here to my variables key. I'm going to press the variables key. Okay. I need a y variable, so I have to right arrow over to the y variables. We are dealing with functions. This is an xy function. And number 1 is y1. So now your screen looks like this. You're going to make a scatter plot of L1 and L2. You're going to get the regression line. And then you're going to tell the calculator to graph it. So now I come down to the most important part, and I calculate the equation of the regression line. Notice that I get R squared, which is my correlation coefficient, 0.8736 squared. But let me just reiterate. If your screen didn't look like mine previously, if it just says linear regression, what are you going to do? You're going to hit second and the number 1 so that you get L1 on the screen. You're going to use the comma to separate like we've done before. Second and the number 2 for L2. Another comma, and then you're going to get to get y1, you're going to press variables. You're going to press y variables, function y1. Now we press enter. So now not only have I got my equation of my least squares regression line, but now when I hit graph or zoom 9, it graphs the line with my original scatter plot. Pretty helpful there. So a lot of work and heavy lifting here if we were going to do this by hand, but we got our correlation coefficient, 0.874. We got that off the calculator, and we didn't need to do a whole lot of work for that. So that's a strong positive linear correlation. Okay, and then the rest of these slides goes through how we would go about doing this on the calculator, and we've already done that. Okay. So we are not going to focus a whole lot on how to test whether this is significant. This comes after we would study statistical inference. But you may see a question or two asking about this. We would just look at a table and we can see whatever our sample size was, and we can look at what our R value was and see if it's significant based on that. But you're not going to have to really answer that question. I just want you to be aware of it. That's how we would do that. We would look that up in a table in the back of the book to consider whether or not it's significant. But we're not going to do any of the hypothesis testing in regards to R. Okay, so 9.2 is where we move forward, and I already did this in the video. You just saw me calculate the equation of the regression line. But I'm going to add a couple of wrinkles to that. One is our residuals. Every time we create a regression line, notice the regression line doesn't hit every single point. In fact, sometimes not a single point lives on that regression line. We always have this measurement error. The reason we call this the least squares regression line is that if I built squares off of all of these residuals, this line is the line that has the smallest area of squares. It's the line that is the best fit. It has the least amount of error. We calculate the error by taking the observed y value. So the observed y value for D4, that would be this point up here, and then the predicted y value is the point that lives on the line. We can plug x values into the equation for y and get predicted values, and the difference between those two, we call those our residuals. Okay, so our line of best fit, I just showed you how to calculate that. Right, you go to stat, calculate L1, L2, and here it is. This is the same data, luckily. So a lot of heavy lifting to calculate this, but if you notice, that's the same equation, 199.535, that we have on our calculator. Let's bring that back up. 199 is my slope. That's the number that gets multiplied by x, and then the y-intercept. And we also have our r and our r squared. Okay? So that's a major technology piece to regression and correlation, that we can make a scatter plot like we did previously, calculate the equation of the regression line, and graph them on the same screen. And then the residuals, of course, are your actual value minus the predicted value. So we can take all these values and plug them into a least squares equation. That's all we're doing here. If I have this least squares equation line that we just calculated, I take this x value of 1.2 and I plug it into the equation, 199.535 times 1.2 plus 56, and we get our predicted value. So that's all I'm doing here with each of these predicted values. We plug them in to that equation of the least squares regression line and get predicted y values.